Good day to everyone. My name is Darren Anthony John, and today I will be talking a little bit about desalination and desalination in salt water, particularly, and I'll also be conducting a mini experiment, a home experiment to illustrate desalination. So, without further ado, I will share my slides. So, 97% of the water on Earth is said to be salt water, and some experts suggest that by 2050, 25% of the world's population will be living in water-stressed areas. As our freshwater resources are slowly depleting due to things like contamination and pollution, we have to turn to salt water, which constitutes the majority of water on the face of the earth. Salt water has to be processed in order to become suitable for human consumption and use. Removing the mineral content of the water equates to less hardness and turbidity, making it more palatable. So we start understanding the importance of harnessing our saltwater reserves and resources, given that it is a majority of the water that we have on Earth. And so that is important for sustenance, given the impending water crisis that we have. So desalination is basically the process of removing mineral components from saline water, commonly salts and other minerals. But salinity is mostly caused by salts. That's important to note. And desalination is at the same time naturally occurring to a certain capacity. This is because this is clearly seen in the water cycle, where the heat from the sun evaporates bodies of water, even seawater and ocean water, which is basically very saline water, and it evaporates that water, and fresh water falls back down as rain. So that is probably the most natural and simplest way of desalination that we see. And so there are two main types of desalination. We have thermal desalination, which is mostly done by distillation. So this is the flow of distillation in which we have seawater heated up and then cooled to produce fresh water, in which the salt is deposited during the evaporation, the condensation process. And we also have reverse osmosis, which is basically distillation but without the heat. So instead of heat, we use pressure in order to treat saline water to get purified water. So the water is passed through a semi-permeable membrane with high pressure, which results in obtaining purified water. So I have done a home experiment in which the aim of the experiment was to produce fresh water from simple distillation of salt water. And the scope of the experiment would be the desalination of salt water of a known concentration. This is done via simple distillation of salt water mixture, in which the concentration was 1 mole NaCl. So 1 mole of NaCl meant 58 grams per liter of salt in the water. The expected outcome was for the water that was collected via the distillation to be fresh water or desalinated water, which is drinkable at the same time. The materials and methods that were used was, first of all, the method was a simple distillation method, and the materials was 2 metal bowls, 3 kilos of soil, which in this case was clay, a heat source, in this case was a charcoal fire, 2 clear glass bottles to see the distillation process happen, approximately 300 ml of 1 mole NaCl solution. So now we'll take a look at the video in which the experiment was done, and I'll be providing a commentary voiceover while the video is playing. So this is our experimental setup. We have the charcoal fire on the left here, and we have the soil. First of all, we have the charcoal fire, which is the heat source needed for distillation in this charcoal stove. The metal bowls were used to house two quantities of soil, so it's approximately a kilo and a half on each side, and this was actually used to conduct heat and to help cool the bottle at the same time. So these were the 2 glass bottles that were used. See-through glass bottles were used so that we can see the process and the changes happen over time. So this is why it was important to use see-through glass bottles during the experiment. And so 1 glass bottle was where the water will be heated and evaporated, and the other glass bottle will be where the water is cooled. So this is how distillation will occur. And this is the salt solution being poured into the bottle. We needed a right amount in which the it would sit comfortably in the bottle like that, so that it's not overflowing into the bottle. It will just evaporate and then collect on the other side. So as we can see here, the experiment is being set up, in which one bottle will be used for heating, one bottle for cooling. So the bottle on the left is the one that is being used for heating, the one with the solution in it. So the salt solution is being placed on the bowl of soil. The bowl of soil actually acts to conduct heat through the bottle, because we don't want direct heat to the bottle that may cause the glass bottle to crack and explode, worst case scenario. So we use clay to distribute the heat evenly throughout the bottle at the same time. And also on the other side is to cool down the bottle, to dissipate heat from the bottle via the soil. Also, clay was chosen due to availability. There is no particular reason or right type of soil. Any soil that can conduct and dissipate heat at the same time is okay. And so the experiment begins. Everything is set in place, and now we are just waiting for the water to heat up and start boiling and begin evaporation, as we can see here. So we will track the process or the changes on the left side, which is where the heating and the evaporation is happening. As we can see very quickly over time, the water is begin to vaporize at the side of the bottle, showing that it is indeed absorbing heat and it is beginning to undergo evaporation. So as we can see here, this process takes a while, so we are going to have to wait a little bit. While this process happens, we can already start seeing steam come out from the bottle, the side where the heat is being added to the bottle. So steam just shows that the soil is heating up and that it is dissipating heat throughout the bottle as it fogs up. So the deeper and deeper it fogs up inside the bottle, shows that it is indeed starting to evaporate and vaporize at the sides of the bottle first before it moves on to the other side. And so now the experiment is going on. We are just waiting for the process to happen, and it will take some time undoubtedly, because we have to wait for the water to start boiling and then start evaporating in order for the distillation to be a success. Now we can see over time there are some changes on the right side bottle, in which we can see that it is becoming slightly more cloudy on the inside, showing that there is something happening. We just don't know what yet. So this is the distillation coming to action. Granted, the setup of the bottles are not exactly ideal, but this was working nonetheless. So the efficiency of the method may have reduced, but in essence, in principle, it is still very much distillation. So as we can see here, we have actually collected some water on the right side of the bottle, and it has fogged up as anticipated. So seeing the collected water shows that it did evaporate and condense in the right side of the bottle. And as we zoom in, we can start seeing the salt crystals that have formed at the mouth of the bottle, showing that indeed, yes, distillation has happened. Salt has been removed from the water, and at the same time, um, given that it accumulated at the mouth of the bottle, it shows that indeed it did manage to move across the other side of the bottle, the vapor I meant. So at the end of the experiment, I tasted the water to see if it was indeed fresh, drinkable water as opposed to the saline water that went in. And the result of the experiment was that, yes, indeed, it was fresh water. There was a minor salt taste, but apart from that, it was very much drinkable. Perhaps at better efficiency of the experiment, it would have given better results in terms of the end salinity of the water. So the results was that, first of all, fresh water was obtained from the experiment, and at the same time, salt crystals were observed at the mouth of the bottle, as shown in this figure here. The conclusion was that the conclusion of the experiment is that fresh water was indeed produced from the distillation of salt water, and the aim of the experiment was reached, and hence the experiment was successful. And for the reflection, we have two parts of the reflection. First of all, the reflection on a whole in terms of desalination in real world conditions, and then self-reflection. So the main concerns of desalination are that it is very energy intensive in terms of a plant setting. It has high cost and, of course, the environmental impacts that are associated with it. And at the same time, the main benefit of desalination is that it is a stable and common process that reliably obtains clean water. All right. So I would like to focus mainly on the environmental impacts that is the main concern of desalination. So the process of desalination creates brine as a byproduct, which is highly saline water with a lot of with a high concentration of salt, and this is being released back into the ocean once it's done. And this byproduct is potentially harmful towards marine life. Overall, doing this experiment, it definitely made me read up and get to know more about desalination as a whole, because all this while I knew that desalination was an option, but I never knew to what detail. I never knew how it worked, how things were done, and all of that. And for the experiment, definitely it was fun doing a outside of classroom experiment instead of just a case study or something like that. So ultimately, I would have to say that this experience was a great one, and no regrets at the end of it. So that's all from me and desalination. So thank you very much.